My name is Deepak Pratap Singh Kera, and today is 28th of April 2023. Good morning, everybody. It is such a pleasure to have Kimi, Pravita, Richard, and Michael yourself here. Today, I am your instructor for this ITG micro presentation session, and we are going to discuss about a very interesting topic, that is electricity safe? But before we get in the topic, let us just start with our introduction. Though by now we know each other quite well, so I would like you to just mention as an icebreaker your first instance when you did realize that electricity is rather a thing of caution. Yeah, we all may have some experience with electricity. It never had been fatal, that's why we are here. But then electricity can be fatal. Yeah, so I will start with myself. I am Deepak Kera, and I have worked offshore. I am a hydrographic survey engineer by profession, but currently I am an instructor here in Plymouth at Figaro Academy. I have been training and teaching quite a lot all those years. I had been an instructor in India, I have been an instructor in the Gulf, now I am here. So this is a thing which I enjoy very much. So shall we begin with Pravita and then we can follow on? Great, thanks Pravita. Richard, how about you? Yeah, Kimi, how is it for you? Okay, Kimi, yeah, that was insightful, and yeah, it brings us to the point that we have to be cautious using electricity, and also that the fatality of electricity may not be just the electricity itself. It could be the shock of getting an electric shock. It could be heart attack, and it could also be the burn. So we will discuss all about it. Hope we will have an interesting class. But before we begin, let's discuss about health and safety. So as I see, the fire is the only thing that can interrupt us. We here at my place do not have any fire drill going on. So if there is an alarm, that will be actual fire. I believe that is the case with everybody. So if you find time to ping that there's a fire, do it. Or otherwise, if you want to straight away leave, because that would be also a right thing to do. So to have it an inclusive class, I would encourage everybody to participate. I have chosen this topic specifically because we all know what electricity is. So we can all talk about it. And the more we discuss it, the more we learn about it. So that is the basic intention. So we will have an interactive class. And I will assess as we go. And then at the end, I would put the same questions so that we know that we have picked up. Just ground rules before we begin, if we don't mind, and just avoid distraction, we can put our mobile phone to silent, though the mics are silent most of the time, so it won't interrupt us much, but it would interrupt you. So it would be a good idea. But if you have an urgent call, please feel free to take it as quickly as possible. Breaks and refreshments, as it is going to be just a 20-30 minute session, I am not hoping to take a break in between. However, we will have a break at the end of it. And if you need to have a water or a drink or a tea, go ahead with it. Only food is something which you won't want to be having on the screen, but otherwise it's all right. Introduction and icebreaker. So as an introduction for me, as an icebreaker, I would just ask a question and probably a small joke. So do you think we can get a shock without being in physical contact to electricity? So this is an open question for anybody to answer. So the question is, can we get an electric shock without any physical contact with electricity? Okay, anybody else? Okay, well, when I came into UK, it was winters in January, and when I opened my first electricity bill, I got a shock. Let's come with an aim and outcomes of this next 20 minutes. So we will be able to understand the fatality of electricity. That is what I want to emphasize upon. Then we will be discussing about the conditions that could aggravate the fatality or that result into a fatality. We will elaborate about voltage, current and resistance and how it is related to the incidents or fatalities that we face, just as the one Kimi mentioned, so that we get a better perspective of what actually happened at that place. Yeah. And then what precautions must we take and how do we review our environment, because we get so used to it that anywhere we go, we don't care anymore about electricity. Yeah. And then we hear about electric fires. Yeah. So just to create an awareness among ourselves, I work on board ships. It is a rather hazardous area and we always have to be very cautious. So this is something we cannot be complacent about. So here let's begin with the class itself. All happy? Any questions, anything? Perfect. So the first question is, we will make it interactive one with question answers all the way. Yeah, because everyone understands and knows about electricity. So do we all think that electricity is safe? What is your opinion? And I would like everyone to answer. Yeah, Pravita, what do you think about it? Yeah. Okay. Yeah, Kimi, your take on it? Yes, perfect. So I believe that though we had seen incidents and experienced it in a way, but still we use electricity, right? So we somewhere believe that it is safe if we take all precautions and if we use it with care. Yeah, I hope everyone will agree with this one. So moving ahead, the next question is, because most of us, our household voltage is 230 volts, except you if you live in America, Canada, Mexico, some other places, but it is two. Do you think 230 volt is sufficient to kill? Yes, everybody agree with this? Yeah, so that is true. 230 volt, though it is not always the case, because most of the time we just get a tingling feeling or something and we are all right, but it can be dangerous in certain situations. Yeah, that basically is if we have a good contact with the live equipment, and the person concerned may get powerless to leave hold of the contact, and then if the duration of the contact is extended, the limbs can get really paralyzed and you may feel out of control to get away from it, and it can lead to severe burns. Yeah, so it is fatal. Do we take electricity seriously? Now, this is a question which you have to be true to yourself. You don't have to be true to anybody else but yourself. Yeah, so what do you think? Do we take electricity seriously? Yeah. Means in your own personal life, means let's say, how do we know if we take it seriously? It is if we are cautious of it, right? If we go to a new place, a new circumstance, and we plug in something, so are we sure we are plugging it in the right way? Are there any loose connections? Yeah, then we know we are serious about electricity. But if we just go casually plug everything in and start charging, and then it's a casual approach. So what do you think? Do you take electricity seriously? Yes, Richard. Okay. Yes, that's true. Usually it also happens that when we have an incident, not to look like a fool or something, some of us may avoid talking of it, but that's not a good idea. We should always talk about it. The more we talk, the more we learn. Yeah, and then basically it should result in a physical change of our outlook. So when we are in a new place, let's say in a hotel or somewhere else, even in a rail and even on a plane, when we are charging something, we should be sure to see that there are no loose connections out there, or the connection that we are making is not loose, because simple reason is any loose connections results in sparking, and sparking is the one which results in fire. Yeah, so there are many instances that happen, but not of us come across, so we may at some time become casual about it. That is the risk. Yeah, and so that's why this topic is here. Almost everyone, I believe, almost everyone, but I still put almost, have received a shock or two, but none the worse. Yeah, many, it's true, had a lucky escape from a serious trouble, because the contact was very momentarily, because initial reaction for body muscles is to push you away. Yeah, so that's a reflex action basically that saves us. So not everyone comes to know of many fatal incidents due to electric shock, therefore the tendency is to become indifferent about it. Yeah, but that is where is the concern. So what causes a electric shock? Now we are getting in the topic. Yeah, is it voltage, it is current, or is it a resistance? What do you think? Yes, okay, that's all right. Yes, Kimi, what do you think? Okay, usually it's all of them together, but the most that influence electric shock is the current. Yeah, so if we get an electric shock, a burn especially, then it's the current. So current is the one when the electrons are actually moving. Otherwise voltage is a potential difference, and it is the current that, yeah, but I will talk more about voltage also ahead. It would be interesting. Current itself is obviously dependent on voltage and resistance. Yeah, but it is the current that causes all the burns and everything. Is high voltage more fatal? Like if you see in an industrial or situation, there may be a 3-phase 440 volt. In a home environment, it would be 230 volts. In certain parts, there is like 120 and 115 volts. Yeah, as a household electricity. So do you think which is more safe and which is more fatal? Is it 120 which is more safe, or 230 is it more safe? What is your opinion on it? Or what do you think about it? Yeah, that's true. The higher, yeah, the higher the voltage, the more current, and it can be more fatal. Nevertheless, there had been instances in America where it is 110 volt that people got fatal shocks. Yeah, but then the situations have to be ours. Yeah, the situations are the one, means if it is a wet condition. Otherwise 110 is reasonably safe voltage, right? But if it is a wet condition, then that 110 volt can actually result in a severe shock. Yeah, so we have to be careful, especially in wet conditions, like when we are in bathrooms, right? We should be very careful that the water is not pouring. You put the shower in a direction that the water is pouring on the socket itself, and then you plug in something, yeah, leading to a short circuit. So bathrooms are one thing. The other things are the outdoors, when it is raining, or in places where it is moist or wet. Yeah, so because we can find plugs everywhere nowadays, yeah, in open areas, but we have to be very careful. We have to see that the inlet do not have water in it. Yeah? So those are things which aggravate the voltage. Otherwise, generally below 80 volts is considered safe. You will get it considered safe. You will get a shock or a tingling feeling. But beyond 80 volts, whatever it is, you have to be cautious. So even 110 volt will be fatal. But the more you go in an environment with a higher voltage, let's say industrial environment, you have to be more careful and you have to keep yourself safe. So 80 volt is something which we consider as a benchmark, but don't take it like literally. It depends on how good the contact is. If you are holding it tight, and if the environment is there, and then how long the contact has been in there, right? So you must have watched in films where they give electric shock to prisoners or people. So he is not dead, but he is like, so that is because how long the shock is and what the volt is. So it's a balance of that. Yeah? So just to be aware, it's painful. So even 50 volts can prove fatal. Yeah, if but that has to be exceptional case where everything is going against you and you run out of your luck. Okay, why are wet situations more dangerous? So what do you think? Why are wet? Just now we discussed that wet situation is dangerous, but why is it so? Yeah, means to put it very simply, it is that water is the conductor, is a good conductor, right? So any loose connection, anything, and there is moisture or water, it will conduct. Yeah, the electric will pass through. Usually what happens, our body, depending on individual, it has a resistance of 100 kilo ohms to 500 kilo ohms. But if we have a wet skin, then our resistance is just 5 kilo. So basically what happens when we are on a wet surface, it's not just the skin. Even if we are on a wet surface and it's wet below our feet and we get in touch with any electrical conductor, so we become the path for the current to flow, right? So wet situations are very dangerous. That's why we must use rubber gloves or shoes, something. So let's take the practical aspect to it. Somebody is in a shower, right? And for some reason it gets in touch with the open circuit and there's an electric shock. What can you do? Or what will be your first reaction? And what else? Anybody can come in. Pravita, what do you think if you just happen to pass by and you see that, let's make it a bit more concerning to you, your son is there and you see that he has electric shock? What will be your reaction? But how do you help? That's the question. Yeah, Kimi, what do you think? Okay, so it's all right. So I think this session would be a learning experience for anybody. So if somebody you find is in a bathroom, he's wet and he has got electric shock, and he's there in electric shock because he is not able to release it, right? The muscles out of control now. So the best thing you can do is turn the power switch off. Just turn the switch off. Usually, yes, and it's simple. Yeah, but because we are in a situation panic, we may not do it. But when we discuss it here, we think about it, and then we are in that situation, most probably we will remember to turn off the switch. That's electricity is gone. Now it's a normal burn. Is everybody with me? Yes, please. Yes, certainly. See, I'm coming to that one. That would be the second thing. Let's say you are not able to find the switch. Certain bathrooms don't have switch inside; they have switch outside, and you want to make it in a rush, right? So had it not been that she's in a bathroom but she's not wet, the hairs are bad conductors. They are not good conductors. So if the other person has got long hairs and if they are not wet, you can pull the person by hair, right? But then they should not be wet. Yeah, otherwise you are the another one who will be in the line getting the shock. In a situation where it is not a bathroom but some other place where we have winter clothing or padded clothing, then they may be like insulators, so you can push it. Otherwise, if you are having slippers or shoes, it may not sound right, but you can give a shove with your shoes, whatever you are putting, if you have putting on, they are not wet, right? And you have to be sure that wherever you are standing is not a wet place, because we are talking about bathroom. If it is a wet place, you have to be again cautious. You can use something which is a non-conductor, like a wood cardboard, yeah, to get the, so that's basically common sense. But sometimes in these situations, common sense is the last thing you can get at, yeah. So then it is practice of having knowledge of it, just giving it a thought, yeah. So that helps. So I hope this session would help, may help, yeah. And we are getting a bit insight. So yes, wet situation, the body contact resistance is low, and even a small leakage can be dangerous. The severity of electric shock is by various factors. It is the passing current, means how much resistance is your body giving to the flow of current. The current takes the path of least resistance. So if it is getting a path of another way where there is a lesser resistance than you won't get a shock, right? Yeah, so you have to make a contact with ground. We see pigeons and all on the high tension wires. Very all right. So because they are not making the circuit complete, they are not touching the ground. Yeah. So that is the thing. So it depends. Then if it is the current passes through your vital organs. Yeah. So if you have a hand and then leg grounded, then it will pass through vital organs. But if it is just the legs, it may not. Yeah, you may still be able to sustain. Yeah. And then the duration of contact. The other thing, if the electricity is a direct current or an alternative current. Yeah, we will come to that. So the next one is resistance decreases with the area of contact and the contact pressure. So if the area of contact is big, then you have a larger chance to get a, but if it is short, let's say a small finger in place of a whole fist. So a small finger would have a lesser impact, but a whole fist holding to it will have more. So we have to be very careful how to deal with it. Now just to put it in perspective, if the current is from 1 to 8 milliamps, it would be, you would realize it, but it won't be painful. But anything which is from 8 to 15 milliamps, you would get to know of it because it will give you a shock. But you won't leave your muscular control will be there, and you will be able to leave it. Yeah, at will. Also the reflex action will kick in, I believe. But if it is from 15 to 20 milliamps, then that will be a painful shock, and you may lose the muscular control. 20 to 50 milliamps, there would be a severe muscular contraction, and you may face breathing difficulties. Yeah. Some people who get in shock, they have like organs misfunction, like loose motions for a couple of days. Yeah, they can experience this one. Yeah, 50 to 100 milliamps, possible ventricular fibrillation, which is like our body, it has got electricity, right? Our heartbeats, it is because there is electric current there, and there is a frequency to our heartbeats. So what happens if it is a alternative current? We have the alternative current, the frequency usually is 50 hertz. In some cases, it is 60 hertz. Because if the alternative current is there, even if the current is not very high, the frequency might disturb our frequency of the heart, which can lead to a heart attack, right? And you may die not of current but of a heart attack. Yeah. So that is another thing to consider. And 200 milliamps above means that is when we get burns. That is because of current. Yeah. Because and it would be more severe in the vital organs and the part of contact. Yeah, so just to put in perspective, the Ohm's law means if the voltage is high, it will be able to push the current further. So higher voltage, higher current. But if the resistance is high, it restrains the current. So it depends on the body resistance. That's why wet conditions are more fatal than otherwise. So Ohm's law is basically voltage is equal to the resistance and the current. So both are inversely proportional. If the resistance is high, the current is low. If the current is high, the resistance is low. So if the body resistance is high, you are having an insulator, you are having gloves, then current won't be there. Yeah. So just so that everyone understands what it is. The real measure of shock intensity lies in the amount of current, yeah, forced through the bodies. It is not the voltage. Yeah. Voltage, if you get a heart attack out of a shock, then it's the voltage. Otherwise, it is the current. So 12 voltage, let's say, if we have got a battery, a car battery, and we are working on it. So it is not a shock hazard. It won't kill you, but it is a burn hazard. If you get 12 volts shorted, it will just burn the whole cable and many cases the car itself. Yeah. So shorting of 12 volt can be dangerous because of the potential, electromotive potential of the battery. But if you happen to touch it, right, it may give you a shock, but or a burn thing in your fingers, but otherwise 12 volts is all right. What is more fatal? Is it AC or is it DC? So after our discussion, this is the question which I want to ask you. So what do we think? What is more fatal? Is it AC or is it the DC, the direct current and the alternative current? Is it? You need to think twice, because if we see the direct current in general, it is 12 volt battery, 48 volt battery or something, we can have it more. But in general, because the AC has the frequency element to it, yeah, the alternative current, which is our household electricity, has a frequency element to it. It can interrupt with our body. So even with lesser current, it can be more fatal. So that way we consider alternative current to be more fatal, yeah, corresponding to DC voltages. But both are fatal. Both are like, you have to be careful about both, yeah. So now almost we are coming to the end of our discussion. So how is it then that some has escaped death even at 100 kilovolts? So how does it happen? You must have heard stories like, yeah, working on high voltages, did survive, was okay, is all right. Have you heard it? Okay, so here we come to the part of the safety precautions that are there inbuilt in a good circuit. It is the breakers, the trip breakers. So if they see that suddenly the current is high, they trip. So many times what happens, if the breakers are all right, of the right value, they will trip and you are safe. You will get a shock. You may feel a burn, but you are safe. So that is because, so we have to be careful that the safety mechanism is there. Yeah, the breakers, the relays are all right, of the right value. So that is one thing, especially in a household also. The AC breakers should be different than the other breakers, right, of a different value. So you have to be careful. If it is not there, check it today and see that it is proper. The geyser breaker should be separate, and it should not be that AC and geyser is on the same breaker, right? So these are certain mistakes which are made in household conditions. Have a look, talk to your electrician. Don't do anything yourself, but you must have an idea of how it works. Yeah. So anything which is consuming higher current should have a separate breaker. Home electricity should be separate. That's a smaller breaker. Yeah. So those are the things. So usually that is a very rare case of miraculous escape, and it is because the breaker has tripped, or that muscular contraction, the reflex action, that the body was thrown clear after the initial voltage, and then but if it stays for a while, then it's very, very dangerous. So high current values do not cause heart failure. So high current won't cause heart failure. It is the alternative current, but it can cause burns and flashover, and one may die even of a shock, if not of electricity. Yeah, it's precautions. So this is the practical part of it, which we must understand. Most of us know about it, but we must review it time and again. Check your installation for soundness. Insulate the wiring. Earthing is important. Nowadays, a lot of equipments are coming with plastic body. They don't need earthing. It is like a fridge that probably will need earthing. Microwave that may need earthing. So be sure that the earth connection is there. Sometimes we may have 3-pin connection, earth is off. It's not even connected. Be careful about that. Yeah, correct size of fuse rating, which we just discussed. Never handle electrical appliances standing on a wet floor, or try to even replace a burnt lamp if you have a wet floor or something. Yeah? So that is important. Don't have electrical devices when it is in a wet situation. Yeah. And the other thing nowadays is that we have one adapter, one plug, and we connect lot of things like our laptop and our mobiles, everything to that. That is very unsafe. It increases the current rating, can lead to a burn in the adapter. Yeah. So whenever we are working on, don't use one power out. Use segregated. Yeah. And always inspect the cords of your laptop, mobile chargers, and especially at the ends where it can bend. Yeah. So at the end of it, educate yourself about the dangers of electricity. I hope this session was interesting. Let everyone know where the main switch is. So that should be your first reaction. Once you turn off the switch, then it is even if it leads to a fire, then it's a normal fire. Like Kimi said that we have to use C-type class of fire extinguisher for electricity. But if you just use a little common sense, because C-type of extinguisher are rare to find, just turn off the power, then it becomes a normal fire. And then you can use A-type fire or a B-type fire, let's say if it is in a kitchen, the B-type fire extinguisher, which are for gasoline or oil. Yeah. So that comes to end of our discussion. Hope it was interesting. If anybody have any questions, please feel free to ask now. So all good? Yeah. So after the questions, basically our learning outcomes, as we had discussed, it was understanding the fatality of electricity. I believe we get it now. Yeah, so if I ask what is more fatal, it is AC or DC, what do you say? Okay, perfect. It's the AC. Yeah. So the other was to discussion conditions that could result in aggregated circumstances for the fatality. So what do you think? Perfect, perfect. And if we do, so we understand what the relationship between voltage, we understand resistance by the body and the current. And the last one was the precautions that we must practice. And when we are in a new environment, we must be cautious. Yeah, we must check if we are not putting everything in one point. All those small things, but they make a big difference. So I hope we met the learning outcomes. So please feel free to provide your feedback. Okay. So Michael is indicating to stop it because I think we have run out of time. I must thank everybody for your participation and for your active participation and interest. So thank you, Kimi. Thank you, Pravita. Thanks, Richards. And thank Michael for your time and your participation. Thank you very much. You had been an awesome audience.